Hello friends, welcome back to the bench. Today I'm going to show you the version 1.0 of a Rework Pro software, and we're going to use it on an IR6500 rework machine. And what we're going to do is we're going to remove the MCU from the ECM. Now, this chip doesn't necessarily require a IR station or rework station. You can perfectly perform this replacement with just a hot air, mainly because there is no ground plane behind the chip. But even if there was, this would still be possible to be done with hot air alone. However, what a rework station gives you is the ability to control the temperature more precisely and replicate your process, which in some cases is extremely important, especially if you work on the same devices over and over. It's especially useful for CPU socket replacements, perhaps GPU core replacements, removals, resoldering, rebolling, reflowing. That allows you to store your profiles and replicate them almost exactly, especially when you use the same board. Obviously, if you use different boards, some parameters need to be tweaked, and that's where the software comes in. It makes it very easy to tweak profiles, store them, and you can store a lot more than the controller alone gives you. Step 1 is to prep the board. So obviously first we need to put a thermocouple somewhere close to the chip, not on top of the chip obviously, but because we're going to be removing it, but we want it somewhere as close as possible. So we could place it here. I'm going to place it here because I want it a little closer to the center of the board. So my thermocouple is going to be sitting here. It is very important in this step to first have the thermocouple touch the board. It needs to be touching the board at all times, otherwise the temperature is going to be fluctuating. And as you can see, I used generous amount of Kapton tape to hold it, because there's nothing worse than the thermocouple detaching from the board during the process. It's a pain. You most likely have to just stop the whole procedure, cool down the board, and start all over again. So always clean the board before attaching the Kapton tape to increase the adhesion, and use generous amount of Kapton tape to hold it. The next step typically would be to cover all the components around it, but since this is a donor board, we don't really care too much about it. I'm just gonna leave everything as is, but those cups would definitely have to be covered to protect them from potentially exploding. However, we're not gonna reach temperatures high enough for those cups to explode on us. In addition, the heat will be concentrated here. After that, step 3 is to place it on the machine. Once you positioned your board, tie down the screws so it doesn't move. It's gonna wiggle a little bit, but that's fine. The thermocouple from the bottom heater thermocouple is touching the board roughly where the chip is, but it doesn't have to be exactly in the center. It's only pretty much for reference. And we're gonna preheat the board to about maybe around 160 degrees at the bottom, which should translate to about 120 degrees at the top. So we're going to be monitoring both temperatures, and once it stabilizes at the top, that's when we're going to start the process. So now let's start the software. Now during this procedure, I also recommend placing another camera that is looking at the angle over here, so you can observe what's happening at that low scale. Especially for the socket replacements, and this camera allows you to see exactly when the socket dropped. You don't want to overheat it too much because sockets melt. With chips, we don't have that problem. The chip is not going to melt, and it's going to be able to withstand much higher temperatures than the plastic socket. Before starting the software, make sure you connect the machine to the computer and turn the machine on. After that, just start the software, and we're going to go to the config tab. I have only one COM port, so I don't have to select anything here. And let's connect. You can see that now we're reading the temperature, the current temperature. So if we put the finger here, we should see the temperature going up, right? And releasing it, the temperature goes back down. Now we don't have a profile for this particular chip, and it's going to be different than the ones that the software came with. So we're going to quickly create a profile. So first, let's go to config. Let's call the profile removal. Now, each step needs to have some name. It's not necessarily required, but it's you can just call them 1, 2, 3, or give them some more meaningful names, like preheating. We want to ramp for preheating. Let's ramp 0.8 degree per second up to the temperature. Let's do 160, and let's dwell. So this is MCU. We want to firmly preheat it. Semiconductors don't necessarily like sudden changes in temperature. So we want to preheat it slowly to the reflow temperature. So let's dwell for 60 seconds on 160. Then we're gonna call this step ramp, and let's give it half a degree per second to 190. And let's keep that, because this is we want to keep that maybe a little shorter period, so let's keep it for 30 seconds. Then our actual reflow, again, let's do it for 0.5, oh, that's 0.5 degree per second. And let's go to 220. So that's going to be 30 degrees from the ramp. And let's keep this one for 10 seconds. And this will be a removal step. So 230, this shouldn't require more than 230, maybe 235, we'll see, but probably 230 will be perfectly fine. And this step we will just terminate it manually. So let's do 600 seconds, so that's going to be 10 minutes. Obviously it's not going to be needed, 10 minutes is not going to be needed. Actually, let's reduce it to 300 seconds. So we're going to lift the socket when we're in the state of, or in the step, during the dwell of the step removal, right? Our fourth step. Now we don't need to save this profile at the moment. We could just hit save, and that will save it to our database. We can also update it, but you don't need to save it. As soon as you press start button, this profile seen here will be used. But once the process is started, any changes to this data over here will not have the effect. You would have to stop the process and start the process again. Very important to remember. But we're not going to save it. So we can see that this is going to be our profile. We're going to preheat to 160 over here, then ramp, reflow for a few seconds. So this is pretty much just the ramp from preheating all the way to removal. It's pretty much a single ramp with minor pauses. So first thing that we want to do is set the temperature on the bottom controller. I have it set right now to 195. That doesn't mean that the bottom of the board is actually going to reach 195 degrees. No, it will reach maybe 160 degrees, which means the top of the board will reach maybe 120 degrees. But that's all we need. This is fine, especially for this job. Even for socket resoldering, that would be pretty good. So first we want to preheat. So what we're gonna do is just hit the preheat button, the machine has turned on. And what the preheat does, as you can see, the top heater should not turn on during this process. Most likely it won't. But the act of activating the main controller, the PC410, is going to enable the second controller, the Rex, or whatever, what have you, to start heating from the bottom. So now, what we want to see on this graph, what we want to see is the red line. We can hide everything else and just see the temperature. So we want to see it rising all the way to, well, we'll see what kind of temperature we're gonna get. But what we're looking for is for the temperature to stabilize. So now it's gonna keep growing steadily until it's gonna level off at some point. And that's our point where the board is preheated. It's not preheating anymore. If we need higher temperature, we would have to increase the temperature on the Rex that controls the bottom heater. Now at the bottom in the status bar, you can see the progress, right? It is about 30% done because preheating is set to last for 10 minutes. So after 10 minutes, it will just turn off. The preheating shouldn't take more than 10 minutes, but if need be, you can just stop it and start it again if you feel like it should be preheated higher than that. Our step time is at 4 minutes almost, which means 40% of our process of our preheating is done. The red line, the red graph should start leveling off before we reach 10-minute mark. Okay, the process is finished. Now we leveled off at around 130, which is fine. It's actually a lot higher than I thought because this board is very small. Next step, simple as that. Let's just see the current set point graph and let's see the power. We don't really need to see the profile because we know what we're setting, and we hit start. So first it's gonna set the temperature to 160. Let's get our tools ready for removal. Let's switch to a better view. The big red line tells us what is the set point or the target temperature that we want to reach. The green is our power, blue is the set point. So you want the temperature to nicely follow the set point. That is the goal. Now it's leveling off for the dwell. Now it's going to be 60-second dwell. As you can see, the power dropped a lot just to keep the temperature stable but not heated up anymore. Now our second step, called ramp, is going to go to 190. Again, the power has spiked to start increasing the temperature, and our blue line is climbing, and we want to see the red line following it nicely. That's why you need to place the thermocouple nicely on the board, and it needs to touch the board, otherwise there's going to be a big discrepancy between the set point and the current point, and it's going to be fluctuating. You don't want to see any fluctuations on the red line. Red line should be relatively smooth. If it's fluctuating, something's wrong. Either the thermocouple is detaching or maybe it's completely hanging in the air. You don't want to see that. If we were in the resoldering state, this is where the flux is going to start releasing smoke. So from 190 to our reflow temperature, we want to make it relatively quick, especially for the socket replacements, because we don't want the flux to just burn off before we reach the reflow temperature. Our new target 220, and I'm gonna attempt to lift at 220 because it's possible that it will let loose at 220. It is not moving at 220, so let's wait for our final step, which is 230, and it should lift at that temperature. If not, we're gonna have to increase the temperature, and I'm gonna show you how to quickly do it if you face this situation. Okay, our chip is off. I dropped it as I removed it. It happens. Now at this stage we want to clean the board, right? So we're gonna hit stop and we're gonna hit preheat. So the machine keeps the temperature, the bottom temperature, while we're cleaning the board. Okay, so at this stage we have the board clean. I didn't clean all of it, you get my point though. But we're still keeping the board hot on the preheat stage. So what we would do right now would be replace the chip, put the heater back on, stop preheating, switch to whatever profile. So say with this one, we don't need to, we can delete this step because because the board is already hot. That's the difference between the first removal stage and the resoldering stage. Your board, when you start resoldering, the board is already hot, so we don't need to start the profile like we did before. The same with 190, we can just keep it for 10 seconds. 220 and 230, we probably want to keep it 45 seconds, no more than that. So let's start the resoldering. So our target is now already 190, so we skipped the 160 because the board is already at 151 at the moment. And the process is complete. So now what we did, we just ran through our resoldering profile, which supposedly would resolder the component we would be resoldering. Now in case of this component, obviously we would just use the soldering iron, and this could be removed with just hot air. But what is important here is that you want to complete this entire process in just one stage. Basically from start to finish, you want to do it in one go. The reason behind that is that each board can only withstand this whole process, this whole heating and cooling, only few times. How many times? Sources vary, but anywhere from 4 to maybe 7 times until the board is ruined. This software allows you to relatively easily and relatively simply perform this entire procedure in one go without touching the actual machine. Everything controlled by the software. Now the software is technically it controls the process. It doesn't just upload the curve to the controller and wait for the controller to perform the process. It monitors the process and each step is controlled by the software. In addition, it gives you the ability to create much longer profiles. There's no limit to the profile steps. So the controller is not our limitation here. There is no limitation. It's probably rare that you would need more than 8 profiles or 8-step profile that you can upload to the device. But if you do, this software solves this problem. Now at last, after the procedure, we can just hit save image, and what we can see over here on the screen, this whole profile will be saved as a PNG file, which you can share with the rest of the community to showcase what profile you use for any particular job. For this MCU, this profile should work. Okay, so that's Rework Pro version 1.0 by blackhorserepairs, made in America. If you would like to purchase the copy of the software, the link is in the description. You can purchase it via eBay. Purchasing the software obviously supports the open source work that I do as well. If you cannot afford to buy Rework Pro, there's also an IR6500 software also built by myself, which is free, and well, it's also very useful. But Rework Pro allows you to unleash the true power of this machine. Thank you guys very much for giving me the opportunity to showcase the software. Feel free to purchase it, feel free to review it, and if you have some ideas of features that we can implement in this version, feel free to contact me either via Discord, email, what have you. And I shall see you guys in the next one.